Next is I'll jump into my talk on ParaDrop, which Glenn very nicely raised a lot of expectations of, and tell you a little bit of what we do, what is ParaDrop, and how it works, and how it connects to this whole idea of smart gigabit communities, and how we are trying to use it for smart transportation. So, what is ParaDrop? Let me explain it very quickly. Okay. Yeah, we have a domain called paradrop.org. I think I will go set 3. Okay. So I wanted to give you a quick overview for those who may not be familiar with what is this concept and what is what's called edge computing is the concept that ParaDrop is based on. For that, I'll just briefly say what cloud computing is. I'm sure everybody knows. Cloud computing means you have a bunch of servers sitting in a centralized rack somewhere in the cloud or somewhere in a data center, and all the services that we care about are usually installed there and runs there. It makes life very easy for most people because you don't have to worry about managing these servers, managing these services, worrying about uptime, worrying about power and all these other things. So cloud computing is something that has obviously taken the world by storm for a while. And edge computing is essentially exploring cases where the performance of applications may be less than desirable if you just use cloud computing. Okay, so what happens is if you're sitting in your home and doing some things on an application with high bandwidth video or say virtual reality, and your data streams from some servers that are far away, which are sitting in these data centers, the performance to the end user may be not as great. Okay, so edge computing is the concept that maybe I can take some of these computing capabilities and move it closer to the edge. So you have computers or servers of some kind that are sitting at the edge networks and doing the same thing that the cloud-based data center does. Now, this may appear like, okay, why you're going back, because the whole point of cloud computing was to aggregate things so that you can manage them in a little more efficient and centralized way. And edge computing is, again, distributing this. But this is a concept that is now emerging in a very careful way to support certain classes of applications, like virtual reality and high bandwidth streaming or interactive gaming and lots of other such applications. So what ParaDrop is, I'll jump ahead a little bit, is taking this concept to the extreme and basically saying that the compute platform that we want to offer for applications sit in the extreme edge. What is the extreme edge? The extreme edge, if you think of network infrastructure, it is the last device before it gets into your mobile phone or mobile tablet or whatever you have. And that last device typically is a Wi-Fi router. Okay, so in this room, for example, you have a bunch of Wi-Fi routers, and what we are suggesting is that Wi-Fi router, we don't think of it as a computer, but it is actually a compute platform. The only thing the Wi-Fi router does today is to take data packets and forward it over the Wi-Fi standard and receive Wi-Fi and send it back to other side. And that's all it does, a very limited function. But it is actually a full-blown computing platform on which you can run computing capabilities. It may not be the most powerful one. It's not as good as your high-end server sitting in, say, Amazon or Azure cloud. But it still can be interesting. It still can do certain things. And I know this particular gateway out here is one of our ParaDrop routers. It looks a little bit, somebody told me it looks like a tarantula. That's because it has a lot of, we designed it to be more than a common Wi-Fi router. It has a number of gigabit wireless interfaces. That's what Glenn was talking about when he talked about this gigabit downtown idea that we were exploring, where we will put a lot of these and on which you can put applications that can serve applications, serve users that are within a short distance of this device. And with that, you can actually create some very interesting applications, whether it's in the home, whether it's in a vehicle, whether it's in a city, you can do very interesting things. So I'll give you some examples of what we are trying to do. And the idea is that the ParaDrop will try to do what the iPhone came and did for the mobile phone, right? So if you probably can think back at least 10 plus years or 12 plus years before the iPhone came out, we used to have what we now call maybe feature phones, and all you could mostly do is dial and call. You could do a little bit more because it was a little bit difficult, but it was a very controlled environment where you didn't have any notion of real apps that anybody can create and install. iPhone came and said you can put and download any apps that a third-party developer can develop, and that made the phone a very versatile device. It's no longer a phone, it's a multi-use, multi-application device. And what we are trying to do with ParaDrop is the same thing for the Wi-Fi router, where you could create this app store of applications that can be brought into this Wi-Fi router, and it can do interesting things, and it is not tied to your ISP or somebody like that. It could be anybody creating these apps, and whoever has a smart idea can create it, and the homeowner can decide to install it, or a vehicle owner can decide to install it, and they can try it out, and they can do interesting things with it. So that's what we are trying to do with ParaDrop. So it's a platform that allows us to deploy intelligent services and Wi-Fi routers through virtualization. So the idea is that it is a programmable substrate. That means you can write applications for it. It will not, of course, work in isolation. It will interact with your mobile devices. It will interact with your IoT devices. It will also interact with a cloud service. It does not eliminate the cloud. It just augments it. And you can essentially put these applications on demand into this Wi-Fi router. We call these applications, they are packaged in a certain way. We call them chutes, as in parachutes. That's why the name ParaDrop is used. And it is equipped with multiple interfaces. It can talk Wi-Fi, it can talk Bluetooth, it can talk Zigbee, it has built-in audio now in this particular hardware that we utilize. So you can do very interesting things with it, and it can be a very useful way of developing applications. So I'll not go into the technology too much, but I'll show you how this works from a developer standpoint. So today we have a cloud manager that manages all ParaDrop enabled Wi-Fi routers. So let's say there are 3 homes with 3 ParaDrop routers. And let's say somebody decides to create a new and fancy security camera system. Let's say we call it CCAM. And what is unique about this solution is that the video stream is not going to go into somebody's cloud and be a target of privacy invasion and all that. All this will do is the video from this camera will only go locally to the ParaDrop router, where CCAM will create an application. Okay, that application, what it will do is it will receive this video stream, it will process it locally, and it will decide whether an intruder was detected or not detected. And if there's an intruder detected, you alert the homeowner and so on. Right? So today you can do this, but most of the solutions will take this video stream and ship it to somebody's cloud. You don't know whose cloud it is, and then they will do the same analysis. But the challenge is then, I don't know if you trust that third party where it is sitting, and there is also a huge bandwidth being consumed, because you are sending 24/7 video. Probably one day a year for 10 minutes the video is relevant. So, but you're shipping video for the whole year continuously, and that is so wasteful. Plus, there is this privacy implication. Whereas if I just host the video locally, do the processing locally, and that's the key. The processing can be done locally here using ParaDrop, because we make it a compute platform. Then you can do the same thing while sort of being more respectful of privacy of people, because the data stays local within the premises, and you can always remove it and things like that. Right? So the way this will work is, this company, let's say this developer, CCAM developer, they will have a cloud service, because you want to have user accounts and all that set up. And they will contact ParaDrop to say, we have our cameras installed in these 2 homes, and that's when they will install the chutes into these routers. And once it's installed, the CCAM cameras will talk to the chutes, and that's where the processing happens, and all the activity really resides within this ParaDrop router. Another company can, another entity can do the same thing, where maybe they're doing this energy management. They want to collect all this data from different sensors in the home, and they want to put it again on the ParaDrop router instead of shipping it all to somebody's cloud, because what temperatures different rooms are, what's going on inside the house, they're also very private information, and you want to keep it local. You don't want to send it all to the cloud. So again, they will create their own chutes, and they will install it into those routers. Now remember that whatever the code is, whatever the software is that decides what to do based on certain sensor information. Whether I should open or close some vents, whether I should change my thermostat setting. They are all running in this green box kind of, you can think of, in the router. So they're local, but it's developed by this third party. Okay, so that's sort of the idea of ParaDrop. So we have been using it for many applications, and I want to briefly talk about, I'll take 5 more minutes. I have a big slide deck, but I won't use it all. We are looking at more, we have been doing a lot of work in the home. We have looked at smart home applications where you can do environmental control, you can do, this kind of secure cameras, and lots of other applications. And maybe if we'll have some time towards the end, and I will have a couple of groups show some examples of ParaDrop applications on some home safety examples. But we are now trying to think of, what if I put this same router, same gateway in the vehicle as a compute hub, and we can do interesting applications with it. Okay, so that's sort of where we are headed. And I'll give you a couple of example applications. So this is what our new version of ParaDrop is going to look like when you think of vehicular applications. And we are designing it to be flexible so that you can plug and play a lot of new hardware and other sensing capabilities, like you could have LiDAR and ultrasonic rangers, you have IMU sensors, these are your motion sensors that are on the phone, you have microphone arrays and camera arrays that you can utilize and connect to this ParaDrop gateway, and of course lots of environment sensors, and they can then do all kinds of interesting things. You can think of applications that can leverage this and run some computing locally in the vehicle to do something interesting. So I'll give you a quick couple of examples. One project we have been doing is understanding driving behavior. Now, this is not new. People have essentially tried to develop apps on a phone where what they try to do is, by looking at the motion sensors on the phone, they try to judge how well you're driving. Okay, so they look at your acceleration pattern, your braking pattern. So the phone basically can say, oh, this was a normal brake, this was a really hard brake, and so if you are braking poorly, you're not a great driver. So it can give you some ratings, and there are commercial apps out there that does this. Okay, and then companies have other products of this nature. So what we realized is that just these actions of braking and acceleration does not tell you the whole story, and if you score people based on that, you might actually get wrong outcomes. So for example, if you braked hard because a kid suddenly showed out of nowhere and came in front of your car, that is probably a good thing to do because you saved that kid injury or accident. Whereas if you did that because you were distracted, you were eating your burger and texting on your phone, and suddenly you realize something is going on, then you should be penalized, right? So that's sort of an important thing. And what we realized is, just looking at sensor data like acceleration and so on is not adequate, and you need to potentially leverage video feeds, if you have available video feeds, to analyze and understand why a certain action was taken. So that's where we are using ParaDrop. We basically augmented certain vehicles with cameras, and the cameras, of course, are taking videos. And when an incident happens, like somebody braked hard, somebody accelerated fast, or made a sudden lane change, we analyze the video to determine what caused it, and then annotate it and send it to the cloud. Now, the critical thing here is that because all of this is going to happen on the ParaDrop gateway in the vehicle, we're not going to try and record videos. No driver is comfortable that 6 cameras are looking at them all the time. So the idea is that you analyze it, you make a decision on what happened, you can keep a little snippet of that one incident, and you throw away everything else in the video stream so that you only record what is of importance in analyzing a driver's driving behavior. So we do a lot of these things, and we can, I will jump ahead. I'm going to keep it really short to give you the high level bits here. So we have a whole architecture built based on this idea where we use all kinds of sensing, then we do analysis in the ParaDrop gateway, and we come up with decisions on how a certain driver is driving the vehicle. We augment our gateway to be quite capable of doing video processing. Normally, a Wi-Fi router may not be the best platform to do video processing, so we augment it to do the right kind of compute so that it can do video processing efficiently. And we have implemented this system in a trial version where, of course, it can detect all kinds of objects, cars, speed limits, traffic signals, and pedestrians. And of course, an important part of that is understanding what the driver is doing. So for example, you're trying to turn left, you will turn on the left turn signal, and we want to see that the driver turned the head to look at the left side blind spot. So we can analyze all of these things on the gateway and discard the video, but we know the driver is doing the right things while they're driving the vehicle. So this is one example of what we are doing. There are a couple of other examples we have in the slides where we are trying to understand how to improve fuel efficiency of vehicles. And we have done projects on how to control the acceleration behavior of a car so that you are more fuel efficient than if you didn't use the software system that we have developed. Okay, and we can show that in at least urban streets you can get 15 to 20% fuel efficiency by using such a system. Now, of course, a lot more work needs to be done. It was done in controlled environments, but there is a lot of potential in such solutions. And then the third one, which is, I would say, very ambitious, and we are doing this in our small prototypes, is actually what we call remote control for vehicles. Now, people may wonder, why would you ever want to do that? The idea is that if you have autonomous vehicles, which is obviously something we all talk about, and we'll hear talks about where we are headed with autonomous vehicles, a big challenge that comes up is what do you do when the autonomous function sort of fails or is unable to handle the situation in hand. Okay? And the challenge that comes up is, could you return control to the possible human driver sitting in the vehicle? And the answer is no, because even when I'm paying attention, sometimes if something happens, it takes me a few seconds to react to it. Imagine I'm reading a newspaper, or I'm distracted, I'm talking, I'm watching a movie because it's an autonomous vehicle. And the vehicle suddenly says, okay, take over now. It'll take me 15 seconds to come out of whatever I'm doing and then take control. Okay? So the idea that we had, and that's why it's a little ambitious, controversial, people also hate it, but it's worth kind of exploring the idea that in such an emergency, when the car is going at a high speed on the road and an emergency happened and the autonomous function failed, somebody needs to take control. And if it can't be the local driver, let's put maybe a room full of, maybe it's like a call center full of expert drivers who are trained to take over control for a remotely located vehicle over a network that has to be appropriately reliable. Obviously, with today's network and the call losses that we see, it's not going to work. But that's also a research challenge. But we have demonstrated in small toy scales that you can actually remotely control a vehicle and do certain things. Minimally, that person may just say, okay, I'll go and park the car safely to the side and then figure out what to do next. Okay, that much we need to do. Otherwise, it's a big challenge to have autonomous vehicles on the road. So there's a bunch of examples of this nature. And I think we have used ParaDrop as a platform to do different things. There are many, many potential applications in the vehicular space that I'm personally interested in, my group is interested in. And I would love to have more conversations with people in this room to see what else we can enable at city scale. I know we have worked a lot with Madison Metro in the past, and we continue to do so, where we've done projects of enabling, say, Wi-Fi services on city buses and looking at how to provide more messaging within buses. And I know that Metro has lots of cameras. They have an independent system just for safety and security. And so there's lots of possibilities that we can do at city scale here. And I think I'd love to explore some of those things with folks. So with that, I'll stop. I'm happy to maybe take a couple of questions or a few more if needed. And then we'll move on to the next talk. So thank you. Thanks. Okay. Yeah. Yeah.
Like I'm always the person to ask questions.
That's fine.
So I guess I'm kind of interested. I mean, I'm a complete I'm an idiot in this sense. So I feel like I'm asking a really dumb question, but it seems like I'm trying to get a sense of whose interest is it to prevent. You said this, it's going to be inefficient. Take all this data, take it to the cloud, and bring it back. Mm-hmm. So you want to keep it locally, so you only keep what's necessary, and all this kind of stuff. Is it the internet service providers who are most interested in freeing up all these data, all this bandwidth?
Great question. Yeah. So who cares about why should we save bandwidth? And so I think there are different stakeholders with different interests. Obviously, the homeowner has great interest in privacy, so that's one obvious one where if I am able to provide our platform is actually all software, it's not hardware. So it will potentially run on your regular home access point too. So if I can give a homeowner or a home user saying, here is the software, you put it on your Wi-Fi router and it'll make your data private. Of course, you have to have third-party developers who help you, but then it becomes an ecosystem on which you can do these services. So homeowners or home users are greatly interested. ISPs potentially have a lot of business opportunities if you kind of adopt this model, because now, every home has a set-top box which often is Wi-Fi enabled. So if they convert that into a ParaDrop style router, then they can provide applications and services to the end users, and they can also save bandwidth going up to other networks. So in fact, that is beneficial to them in certain ways. And actually, in the end, the content providers or application developers are also interested, because it makes the experience of the end user better. In certain applications, if you just run it from the cloud, it's not going to be as great as compared to having a solution where there is a edge component.
Like it'll be slower, is what you're saying.
It'll be faster for the end user. The experience for the end user will be that the application runs locally. So my latency to the end user is, say, a few milliseconds as opposed to 100 milliseconds. And certain applications like virtual reality based applications, that's a big difference. A person can get nauseous if your latency between your head movement and the scene change is order of 100 milliseconds. So those applications, they care about such things. So there are many ways of taking advantage of this, I think.